Hello everyone. This is the next video on the GPSR routing protocol. In the first one, we have learned some basics of GPSR like greedy forwarding, how forwarding works, and where that protocol will fail. In this video, we will discuss planarized graph. So, planarized graph is a graph in which no two edges crosses, and here we are going to take these two graphs, RNG and Gabriel graph. So these two techniques actually we are going to use in GPSR for converting a non-planarized graph into planarized one. And instead of this notation, we are going to use this notation. So if a node is connected with another node, it means that these two nodes are in the range of one another. So we are going to take this example for relative neighborhood graph. So this graph is actually having a property. It says that an edge between u and v exists only if distance between u and v is less than or equal to distance between every other node w. So here I have missed the w, so w is also there. Every other node w and whichever of u and v is farthest from w. So how to apply this technique on a graph? So let's say we are having this example and we want to check whether this edge will exist or not. So we need to see all the other nodes which are connected to u and v both. And I have taken only a simplest example. I have taken only a single node. So this node is connected to u and v. And in these two distances, this one is the more as compared to this one. So in order to check the existence of this edge, this 13 will be compared with this one because this is the maximum of these two. So 13, if 13 is less than 11, and so this is not the case. So in that case, this edge will be removed because this is not following this property. If instead of 13, let's assume this is 10, so in that case this edge will exist. And you need to keep in mind that at the time of removing edge, one should keep in mind that removal should not partition the network, otherwise the route will not be able to forward a packet to the destination. Now let's apply this RNG technique on this graph. So here we can see these two edges are crossing. So let's see first existence of this edge. So in order to check the existence of this edge, we need to find out all the nodes which are connected to these two nodes. So we are having only one node u which is connected to w and z, both of them, and this u is uh, more closer to z, and the distance between w and u is higher than this one. So we will take the higher distance, and now we will compare the distance of zw with this one. So 7 is less than 10. In that case, this edge will exist. Now let's see the another crossing edge. So we want to see whether edge u and x will exist or not. So we need to find out nodes which are connected to u and x both. So we are having only a single node w which is connected to u and x both. So in these two distances, we are going to take the higher one. So now we will see whether this distance is less than this one or not. So this is not the case. So in that case, this edge has to be removed and our graph become a planar graph. So the next technique is the Gabriel graph, and this technique says that as UV exists only if there is no other node in the circle whose diameter is UV. So if we draw a circle by assuming this is the diameter of that circle. So this statement says that if there is an edge between U and V in the graph, that edge will exist only if there is no other node in the circle whose diameter is UV. So in this scenario, you can see W node is there inside the circle. So in that case, as U and V has to be removed from the graph. Now the question is that how we are going to decide whether a node W is inside the circle or not. So what we will do, we will find out the midpoint of this U and V. So this midpoint M is also a center of this circle. So if a node is inside the circle, the distance between that node and the circle will be less than the radius of this circle, and the radius of this circle is UM. So we can write a property: if distance between M and W, which is this one, is less than the distance between U and M, so in that case node W is inside the circle and that edge has to be removed. So this technique can also be applied to convert a non-planarized graph into planar one. So in the next one, we will see the example of GPSR routing protocol. Thank you very much for watching.